previous assignment, does anybody have anything they want to talk about from worksheet 4? Roots?
Number 10.
Okay. So for 6 through 11, we're going to be using this relationship. So here, we have to remember that for the natural log, the base is e. My y is 5. And my x is like this 1.609. So if I put that together then in the exponential form, I have e to the 1.609 should be about 5. You're welcome. Bianca, you had a hand up. Did you have a question also?
I had a question about 11, but I'm not sure if I do or don't have a question about. I don't know, but let's just do 11. Yeah.
Okay.
Because I feel like, is it similar?
It's identical.
Yeah, that's why I was like, I don't really. Yeah.
Right? So those are my values for b, y, and x. So I have b to the x is equal to what? That's it. Which again, if you FOILed out 8 plus 1 squared, you get the right-hand side. Anybody else questions from this paper? Yes?
13.
Okay. So remember the base for the natural log is e. So I have e to the log base e. So those will just cancel out. And you're left with x plus 5.
Oh, really?
Yeah. Okay.
I have one more question. For numbers like 3 through 5, are those in the calculator and then calculating like errors?
The last one would be an error, but the other ones wouldn't be. So to do log of 22, you do log 22. To do natural log of 2, you do ln or 2.
Oh, okay.
To do log of 0, you're going to get an error there because you can't take the logarithm of a non-positive number. So the fact that 0 is less than 0, or is less than or equal to 0, is the issue there.
Thank you.
You're welcome. Okay. Well, let's get this show on the road then, huh?
Yeah.
All right. Today, we're going to continue talking about logarithms. Continue. So today we're going to talk some more about properties. And we're going to first start talking about things that you can't do with a logarithm. So we're going to talk about some relationships that are not true. I find that often this is as valuable for students as the things that you can do. It's just eliminate eliminate the stuff like, oh, no, don't ever do that. So we'll start with the oh, no's, and then we'll move on to the, yeah, that's a lot better. The first thing is that logarithms do not distribute. So log of x plus y is not equal to log of x plus log of y. Don't ever do that. You can see that that's something that would be very tempting to want to do. So the same thing is true for multiplication. Log of x times y is not equal to log of x times log of y. That's not true. Everybody's okay there? And you can't combine stuff from outside the logarithm with stuff inside the logarithm. So if I have log of x plus 1, you can't add 2 to the 1 inside the logarithm. Everybody's okay with that? So these are some common things that I'll see students try to do that are just like, oh, I can do that. So let's look at some can-dos. The first one is called the product property. And what the product property says is that log of x times y is equal to log of x plus log of y. And you should look at that and go, boy, that seems kind of odd that the multiplication inside the logarithm turns into addition of two logarithms. And I would say, well, it shouldn't seem that odd. Because if you remember back to last chapter, we talked about this property of exponents, where multiplication between two exponentials turned into addition inside the exponent. In fact, this product property is just the logarithmic version of that property. Okay with that? The next property is called the quotient property. And it says that division inside the logarithm turns into subtraction outside the logarithm. Which now, after seeing the product property, probably is a little less surprising. But again, this has a parallel with our exponent properties that we talked about last chapter. You guys remember this property of exponents, where division of two exponentials turns into subtraction in the exponent. That property of logarithms is just the logarithmic version of that exponent property that we've already talked about. The third one is called the power property. exponent inside the logarithm turns into a coefficient outside the logarithm. Again, that seems rather strange. But if you remember from last chapter, we had this property of exponents, where the exponent of an exponent turned into the multiplication of exponents. This is, or that power property is just the logarithmic version of that property. And the last of these properties is called the change of base formula. So the change of base formula says log base b of a. I can rewrite that as the quotient of two logarithms of any base of my choice. I wrote that base as c, where you have log base c of a over log base c of e, or I'm sorry, b. So this change of base formula was super important when I was in high school and having to do this stuff, because our calculators didn't have this log base option. So if I wanted to do something like log base 2 of 6, I couldn't do that on my calculator directly like this. I had to use the change of base formula, because my calculator as a high school student did have the log and ln buttons. So I could rewrite log base 2 of 6 as, say, log of 6 divided by log of 2. Oops. And it's the same way of doing that. Now, you guys, this is much less valuable to you because, well, our calculators can handle the, have the log-based commands, so you don't have to really worry about this. But there are things later on where this formula could be valuable, but the thing that sticks out from my mind when I did this as a high school student was using it to do these calculations. And before me, when we didn't have calculators that even had the logarithm operation programmed into it, you'd have like a table of values for logarithms. So you'd have like this, like a notebook full of like, log of 2, 2.1, 2.2, etc. And you'd like literally have to like look up these values and then like divide them. It was a pretty big hassle. And that's probably pretty similar to what your parents did, or they might have had to use a slide rule. Certainly my parents were in that boat when they were high school students. So a slide rule was a fancy like, right here. So like, it's this ruler and you use it to do like fancy multiplications and stuff before you had a calculator. But it was built on like these using logarithms to do the so they can turn it into an addition problem and then turn it back into the multiplication answer. But this was what we had to use before we had electronic calculators that were widely available. Because back in like the 60s and 70s, an electronic calculator was like a luxury item. It wasn't like people are just giving these away at like, the bank or whatever. Or it's like, here, have a calculator because you came in and talked to me about setting up an account. That was kind of it. It was a luxury item. Anyways, so those are the 4 can-dos, those 4 properties. In this section, we're going to ask you to do two types of problems. One of them is called expanding. And the goal here is to write a single logarithm as the sum or difference of many logarithms. The other type of problem is condensing. And that's basically the reverse. We're going to write the sum or difference of many logarithms as a single logarithm. Oh, excuse me. So the tools that we're going to use to do these expanding and condensing problems are these first three properties. So if we're expanding, the order that we're going to do things is we're going to look for quotient properties first, product properties second, and power properties last. And if we're condensing, we're going to go in the reverse order. So we're going to do power properties first, product properties second, and quotient properties last. Bianca?
What are we doing before condensing?
Expanding?
Oh, I know.
That's okay. Everybody's okay with what I've described so far? We're going to do some examples now of these kinds of problems. But I wanted to just kind of, start by prefacing things with these instructions. And I'm going to do my examples here on the side because I'm going to refer to these examples or these properties as I'm doing them, but you don't need, you can do your examples wherever, right? I just wanted it to be on the same screen as this stuff. So let's do some expanding ones first. So let's say we want to expand the log of xy squared. So this is an expanding problem. The first thing we're going to do is look for, or try to use our quotient properties. So to determine an expanding situation, if I can use the quotient property, I'm going to look to see if I have something like the left-hand side of the property. So specifically, I'm looking for division going on inside of my logarithm. So if I look inside my logarithm, I see no division, right? So there's no quotient property to use. So I'll move to the next one. The next thing I'd look for is the product property. So if I look at that, what I'm looking for a product property is multiplication inside my logarithm. And I do see multiplication inside this logarithm. The x and the y cubed are being multiplied together. Everybody's okay with that? So to use the product property, then I'm going to use the right-hand side. So I'm going to write this as log of x plus log of y cubed. So the two things that are multiplied together are just going in their own separate logarithms with an addition sign in between. Okay with that? And now if I look inside, I see no more product properties. There's no more multiplication going on. So now I'm going to look at my power properties.
So once you already chose like product property, you keep like choosing different ones, so you have to go through all three of them?
Yes.
Um,
Yes. We want to do all of them that we can. So to use the power property then, what I'm going to do is I'm going to look to see if there's an exponent inside any of the logarithms. If I look at the first logarithm, log of x, there's no exponent there, so there's nothing to do with that. If I look at the next logarithm though, there I have log of y cubed. So that has a power in it. The power property says that that exponent becomes a coefficient. So that's going to be 3 times log of 1. And that's as good as we can do, because there's clearly no powers left, and we've already checked the quotient and product before that. So we are done with that one. Is everybody okay there?
once you like,
Yes.
I'm like a little confused. When you're expanding, do you have, like you said, you have to go through all the properties, so once you hit like say power property, you can't go back to product, or could I ever end at quotient?
Well, you might only have a quotient property that you can do,
Okay.
but you should still check to see if you can do the other ones.
Gotcha.
So typically you don't want to move forward until you've done like all of the product properties that are available,
Okay.
and then you would move to the power property.
Power property. Okay. Gotcha.
Welcome. Okay. So let's do another one. Let's say we're doing the natural log of x squared y z to the third over w to the fourth. So the first thing I want to look for is my quotient property. Do we see a quotient property here? Yes, because there's division going on inside the logarithm. So the quotient property says that I'm going to rewrite that as the log of the numerator minus the log of the denominator. So far, so good. And if I look at the logarithms that I've created, there's obviously no division going on in any of those. So it's time to move to the next one, which is the product property. Here I'm going to look for multiplication inside my logarithms. If I look at the first logarithm, I see 2 multiplication symbols, right? There's one between the x squared and the y. And my one notice rolls in. We're doing so good, one note. We didn't freeze it all first hour. So we have a multiplication going on between the x squared and the y. And also between the y and the z cubed, right? Everybody agree with that? So there's two product properties to do. So that's just going to separate it into that. Or basically everywhere where there was a multiplication symbol, and now I have an addition with a logarithm around the symbol, each thing separately. Is that okay? Bianca?
Oh, no.
Okay. And obviously there's no product property in the last logarithm, the log of w to the fourth, so I just copied that down, right?
So that's not our property.
It is a power property. Yes, we haven't gotten there yet.
Oh, sorry. Okay.
That's okay. That's what we're about ready to do now.
Okay.
Because I just wanted to mention that I checked everything for products before moving on to powers. So I see three power properties. I see one for the x squared, one for the z cubed, and one for the w to the fourth. Everybody agree? So the power property is just going to move those exponents to the coefficient. Anything where I'm not doing a property 2, I'm just recopying the thing unchanged. So the log of y just got copied down unchanged. And that's all I can do. So that's as good as we can do. Everybody okay there? Let's do log base 2 of 2x cubed over yz squared. So you guys tell me, what should I do first? Okay, a quotient property. So what should I write after I've applied the quotient property? Just go ahead and shout it out.
Log 2, and then parentheses 2x squared.
Good.
Log y. Oh, is that y too?
That's a yz squared. So that's good, right? That's the quotient property applied. And if I look at each of the new logarithms I've created, there's obviously no more quotient properties to do. Since none of them have a denominator, there's no more division going on, right? Okay. What would I do next?
How do you use a product property?
Good. How many product properties do you see?
Total 3? Or not 2?
2. 1 in each logarithm, right? I have multiplication between the 2 and the x to the third, and between the y and the z squared. Okay, so tell me what I should write.
I should write log 2, and then cx. What is that?
So that's
Sorry,
a
2.
that's a 2.
Alright. 2, and then Do you do x to the third outside of that?
So now you write plus
And then you do log x to the third.
log base 2 of x to the third.
And then you do the same thing for, sorry. And you just keep like doing it with y and z.
Good. So tell me what to write.
Oh, so plus log 2.
Well, this was a minus.
Oh my god.
Should it stay minus?
Minus log 2 y, and then we subtract again, and we have.
That is a great question. What do you think?
Probably add because it's a new multiplication.
Okay. So you're saying to do this.
Yes.
Okay. You picked wrong.
I did.
But this is the most common mistake I see students make doing this kind of problem. So keep in mind, this whole logarithm is negative, correct?
Yeah.
So its result after the product property also still needs to be negative. So that negative sign should really be distributed through. Now that's tricky. I would say almost all students will make that mistake the first time they do this. And I would say, I don't know, half of them will still continue to make this same mistake no matter how many times I point this out to them. So it is something to be mindful of. It's a very frequent, common mistake. If you're not paying attention right now, I guarantee you're going to make this mistake later on when you take the test or whatever, because I will have a question where this pops up. So if you're not paying attention, that's going to be a problem later on, because you'll miss it in the homework, and you'll miss it the next time on the test, and you'll get that question wrong.
Wait, I have a question. So when you multiply, is it plus, and then when you divide, it's exact?
Yep, that's what the quotient and product properties say respectively. Okay, are we done, or do we still have more to do? Power property is next. Good. How many power properties do you see?
2.
2. One on the x cubed and one on the z squared. Everything else is going to stay the same, though, right?
Yes.
Okay. So those exponents just become coefficients. I'll write that down real quick. So that gives us this. And there's no more properties to do, but there is something else we can do. It's something we talked about yesterday. Does anybody see it? Log base 2 of 2 we can simplify.
Can cancel and simplify it.
So if you remember yesterday, we had this guy here. That log base b of b is 1. So log base 2 of 2 has to equal 1. And that's as good as we can do. So even though that wasn't one of the properties we listed today, it was one from yesterday. So the expectation would be that you still would do that. Is that okay with everybody? Rearrange this stuff back a little bit. let's do some condensings. So when we're doing these condensings, we're using an opposite order. So in the condensing, we look at power first, then product, then quotient. So it's the opposite order of the expanding. And when we're looking at the property to identify where that property is present, instead of looking at the left-hand side of the property, when we were for expanding, we're going to be looking at the right-hand side of the property for condensings. So we start with the power property. To identify a power property, I'm looking at the right-hand side of the property, so I'm looking for coefficients. Do we see any power properties present in example A? Yes, because I see I have a coefficient here. So when I apply the power property then, I'm taking that coefficient and moving it back to the exponent. So I'm kind of using that property in reverse direction. So in expanding, the exponent turned into a coefficient. When condensing, the coefficient changes back into an exponent. Does that feel okay? Good. The next thing I would look for is the product property. So for the product property, I'm going to be looking for additions. I don't see any addition. So move on then to the quotient property. For the quotient property, I'm looking for subtraction. I do see that. So important to note that the piece that's positive is the part that goes in the numerator, and the piece that's got the negative sign in front of it is the piece that goes in the denominator. The order in which you put that does matter. And that's it. So that's our first example, relatively straightforward, right? Yes. Yes. Okay. Our next example here. Again, we're still condensing, so what property should I start with? Power. How many power properties do you see present here? 2. Right? I have a coefficient of 3 here and a coefficient of 4. But all the other pieces just stay the same. So the coefficient of 3 turns into an exponent 3. And the coefficient of 4 turns into an exponent of 4. Everybody good there? Yes, Bianca?
Would it turn into log or would it be ln?
So they just stay ln.
Oh, okay.
Whatever the, so remember log base b includes e as a base, which would be the same as ln. So all it's saying is that the bases have to be the same to do the property,
Okay. Got it.
which will always be what I give you. I won't ever give you something weird where the bases change. Next thing we do is we look for what property? product. How many product properties do you see?
3, 4,
So how many addition symbols do you see? 2. So there's 2 product properties, but that really doesn't matter. What matters is that all the stuff that's being added together just kind of goes together inside of one logarithm. Is that okay with everybody? Now I use 2 product properties to do that, but like, I don't care that you recognize that it's 1 product property or 2 product properties or 3 or 4 or 12. If you just put all the stuff that's being added together in one, I'm happy. Everybody's okay with that? Okay. So there's no more addition symbols, so we're done with the product properties. The last thing I check for is quotient. To find quotients, I'm looking for what? Subtraction. I do see a quotient then. So the positive part is my numerator, and the negative part is my denominator. So there's that. We feel okay with that one? Let's do one more example. And I'll pick a, oops, that wasn't really where I wanted it to go, but that's fine, yes. And here we'll do kind of a sneaky one. So here I have log base 3 of x minus 2 log base 3 of y minus 3. So right away, this feels a little weird, right? What's weird about this one? It has that 3 at the end without any log part on it, right? So my goal here, before I get going using the properties, is to get a logarithm, attach that 3 somehow. Here's my justification for how I'm going to do that. 3 is the same as 3 times 1. Nobody should have a problem with that, right? And we said yesterday that log base b of b is equal to 1. So I can rewrite that 1 as log base 3 of 3. Why did I choose log base 3? Because that's the log in the rest of the example.
Will you always give us one? Or like,
Well, I always give what?
like, it's 3. Was it like supposed to be like that? Or
Okay, so is that confusing? Let's do this then real quick.
just
Let's just make that a 3 and that a 2. And it'll be a little less obvious,
okay, yeah.
or a little less confusing about why the base is 3. So the base is 3, not because the number was 3. The base was 3 because I need the base on the logarithm to be the same. So I'm just making the base match whatever the logarithm is in the problem.
Okay. So I'm going to rewrite it the log 3 stays 3, even though it's minus 2 now.
Yes.
Okay.
Yes. That part at the end had nothing to do with the coefficient.
Okay.
It had to do with the other logs in the problem.
Okay.
Does that feel better?
I believe so.
Okay. Yeah, it was a poor choice of numbers in that problem on my part.
So say it was like log 4, it would be log 4 times 1.
So if this number was, so if these were log 4s,
Yeah.
this would be 2 times log 4 of 4.
Okay.
So the 2 isn't going to change.
Yeah.
Are
Nope.
we demonstrating a property once we put the log
No.
3? Okay.
No, we're using this that we talked about yesterday,
Okay.
that log base b of b is 1. So I replace the 1 in 2 times 1 with log base 3 of 3. Right?
Okay.
That gets me a logarithm in there, so now I can start using my properties.
Oh, okay. I see it now. Okay. Yeah.
Because before, the minus 2 at the end, it's like, what the heck do I do with that?
Okay.
Right? Because there's no property with just a number in it. It needs to have a logarithm attached to it, which is what I did to start the problem. Okay. Powers are first, right? We have 2 power properties. The question for you guys is, should I leave this as a subtraction symbol and put the exponent as a positive 3? Or should I change it to an addition symbol and move the exponent as a negative 3? Yep. So we're going to do a power property. Should I, when I do my power property, should I write this as minus log base 3 of y to the positive third? Or should I write it as plus log base 3 y to the negative third? Should the negative sign go with the exponent or should it stay there? You're both right. It's doing the same thing. It doesn't really matter. I prefer to leave the signs where they are. I think it makes life a little bit easier. But if you take it with it and everything will work out, you can still recover the same answer. But that's an important question. At some point, usually somebody decides they like taking the negative signs with them, which is fine. Everybody okay there?
How do you get a square?
I
Oh,
did the power property. That was the point of getting that logarithm there, is so that I could use the power property on it, right? Is that cool?
Okay.
Next thing I look for is product property, right? Did you guys see a product property here?
Yes. No.
That was a trick question. There is one here,
Really?
but it's hiding. Yeah. So we're looking, is there a product property?
It's hiding.
It's hiding. So here's the trick. You see how these are both negative, right?
Yeah.
So what if I factor a negative out? So I could factor out a negative.
So are we supposed to know to do that?
Well, we've already basically done this already today,
Yeah.
right? So if you looked at this example, remember when we did that and had to distribute the negative?
Yeah.
Because we're going kind of the opposite direction here. Instead of distributing the negative, we're factoring the negative off. So it is kind of the same thing as something we've already done. Would I expect you to have gotten that the first time? Almost no student sees that the first time. Even if we've done it in the exact same order and we did that same thing beforehand, almost nobody sees that the first time. But now that I've pointed it out to you, again, going from almost nobody seeing it, usually goes down to about half of us catch that, and the other half continue to miss it throughout the entire rest of the chapter and all the homeworks. They miss this same little thing and onto the test. But
Part of. Okay.
so
I know I asked this 30 times, but should there always be
no, you won't have to use all 3 of them.
okay, and if we don't,
Then you just skip it, go to the next one.
okay,
In
so
the same
when I'm
sequence.
looking at that problem, I would say no, but now I know that I'm looking for that once I get to that step.
Right. If you see more than one negative, more than one subtraction symbol, It's not two quotient properties. There's only ever one quotient property.
Okay.
If you have more than one subtraction symbol, what you have is product properties hiding in there.
Gotcha. Okay. I think I got it.
So we'll do our product property then, now that we have written it so that we have our addition symbol there. Everybody's okay there? With what we did to the product property? Okay. And then the last step is to do our quotient property. And instead of writing that as 3 squared, I'm going to write 9. Is it just a little bit more convenient?
Would you accept either?
3 squared is fine. Yeah, that's fine if you want to keep it that way. I'm not going to mark that wrong. I'm just going to write it as 9 because it's like one less symbol to write. And I'm that lazy. Okay. So that is the content that I wanted to cover today. So we're not going any further forward. We're just going to stop here. So those of you that are like following along at home, this is kind of the end of the lesson. Yeah. So I do have an assignment for you guys. Oops. Your assignment is this worksheet 5. So the first page is just expanding problems. The second page is just condensing problems. These should all be quite easy. I don't think there's anything really tricky in here at all until you get to these last 2 problems. But the rest of them should be relatively straightforward. I don't think any of them use all 3 properties. I think all of them use just 1 or 2. So that should be relatively easy. So that's what I'm going to ask you to do here for today. We're stopping here, so the next remaining 20 or 25 minutes or whatever we have left in class, you guys can spend working on the assignment.